Hello, everybody. Welcome to the stream. How's it going? Can you hear me okay? I had a bunch of audio problems, so want to make sure that that is resolved. Hey, RJ Helms. Good to see you. Happy Friday. 5x5. Thank you. All right. So I think I can close this one now, and I can close this one. And now we're going to... So, back in the lab, and we're going to work on an old friend of mine, the Mega IIe. Oh, this is not going to work. Hold on. I have the wrong windows open on the streaming computer. Close this and make this big so I can actually see. Hey, crafty nerd. Okay. And then let's do this. Whoa, I am so out of practice. I actually haven't been in the lab almost all week. So this is, yeah, that's more like, that is more like it. Although the new chat program I can't see. So, hey, J Kid, long time no see. Hope you're doing well. All right, so over here, let me minimize this. This one I should be able to see. So that will work out, I guess. Okie dokie. All right, so here's what we're going to do today. A couple of things. I am finally making progress on the Element 14 video for the Mega IIe project. But all of the stuff we did a year ago is lost. My recording settings were messed up, and so all I have are still images of the streams. I don't have the I don't have any of the recording because the encoding settings were set to record at like 100 megabits per second, and it overloaded the streaming computer, and it took me 2 months before I realized that. So, which is okay because, well, it's frustrating because I wanted to save all that, but it's okay because eventually I need to explain what's going on. Oh, that's not what I wanted to do. There we go. What was going on with the Mega IIe anyway. Oh, you know what I don't have on here? All right. Yeah, I'm not going to have the combined chat today. Okay. So for those that don't know, this was a project that we worked on about a year ago. This was the second revision. It's where I've taken a Mega 2 chip out of an Apple IIgs, and we've connected it to, well, a modern 6502. But basically, because of this chip and these boards, we have a fully functional Apple IIe compatible computer using an original chip from Apple, using it in a way that Apple never used. Now, we actually have gone past this version of the project to a full PCB, which will be featured heavily in the video. So what I want to do today is I want to get this one up and running again because I need to do some things with it to shoot some explanations. And I want to try and measure what happens when we hit a couple of the bank switching signals in the Mega, because I suspect the Mega 2 supports the Apple IIc's bank switch soft switch. I suspect it does, and I think I know how we can tell. So that's what we're going to do. But first, what we have to do is clean it off because it's disgusting. In fact, don't look too close at the thumbnail for this stream because it is really bad. I was like, boy, that looks a little dusty. And then I took a picture of it, and the picture is, you can see all of the dust. It is disgusting. So we're going to do this. I'm going to come over to this guy. What? Well, that wasn't what I expected to have happen. Oh, this could be why. It's plugged in. That's plugged in. That's plugged in. There we go. Okay. All right. So there's the Mega 2. And then I wanted to capture this because I'm going to run my dust blower, and hoping we see a whole bunch of dust come off of it. Okay, well, that was really anticlimactic. It didn't clean anything off. Let's try this ESD brush and just kind of. Speaking of ESD, it is a bit dry in here today. So let's briefly pause and let me put my ankle strap back on. I took it off when I went to eat lunch. Yeah, exactly, Unknown. I actually, so for the writing I do for Hackster.io, there are so many projects that I write up that I end up photoshopping the pictures, the project pictures that people have on their website, or like on Hackaday. I actually clean up the pictures in Photoshop because they almost always have a lot of dust on them. And it's just like, whoa, that is gross. So hope I didn't mess up that bodge. Okay. I mean, there's a little bit of irony in the fact that it's, oh, what is this? Oh, we lost the test point. Okay. All right. Cool. So this, okay. So a couple signals that I know for sure have to be connected to something. This is intdev6, which I thought I had a special pin for. I do. And that's supposed to connect to the IWM, which I think is this signal. This is vref. No, that's not vref. That is 5 volts. So I got to find a 5 volt input somewhere. Wonder what I was using to do that before. Because, oh, I probably connected it to the keyboard controller. Oh, that's going to be tough to get to. Oh, is that what this signal is, I wonder? I can almost read the silk screen. Yep. Okay. That's what I did. I connected it to here. Okay. Okay. So I think that's all we actually need to connect. Oh, what is this supposed to connect to? This connects somewhere, and this always gives me trouble. I don't remember where this wire went. I think this is window, and I think I have to use a, yeah, I need a mini grabber. This one is a hairy connection. It doesn't always work well. But, or is this sync? I'm pretty sure it's window. Yeah, I think it's window. Okay. All right. So that should be what we need to hook up to that. We're going to need power, so I'll figure that out here in a second. Yeah, well, spoiler, I did not eat the solder paste. Yeah, if, I can't really, about the only thing I can do on audio is I'm going to move my microphone down a little bit. It's probably going to get hot every time I bend over the computer, though. All right. All right. So power supply is coming on. Now we need some cables, and we'll need a keyboard at some point. Although I think today we're just going to do 5-volt stuff. I don't think I'm going to worry about hooking up to the 12-volt rail. Maybe we'll do a disk drive thing later. But for now, we're just going to go with, I need my floppy MU. Okay. I wish I had my other cable. I don't know where it's at, but that's okay. That's okay. Yeah, I mean, so on the solder paste thing, right after the graphic plays, I show the cake dye that I used, which actually tasted disgusting. I thought the icing would be like sugar, and it was not. It is definitely meant for decoration. All right, so we will hook up a ground here and a 5 volts here. And then, like I said, we're not going to do the plus or minus 12 volts today because we only need that for the a disk drive anyway. And I'm going to use my emulated disk drive, which we may actually not even use this at all. Maybe I'll hold off on connect. Well, I want to connect this to see if it works, so I'll connect that for now. All right, so that's connected. Set to 5 volts. So that's not going to work because we need to change the current on channel 2 to be 500 milliamps. Well, I'm going to try 300 milliamps to see. 100 milliamps. Okay. So that will take care of that. All right. Oh, bummer. I don't have, shoot. I don't have the speaker. Okay, we'll go without a speaker today. It'll be fine. It'll be fine. So this device is the revision 2 of the project that I called the Mega IIe. It is based on this chip inside here. This chip, which came out of an Apple II GS. This has all of the logic of an Apple IIe with 80 column card built into the single chip. And then it connects to a modern 6502, the Apple IIe ROM, some RAM, and then we have a video board over here, which is an RP2040 that talks to this chip to get its video data to output VGA. And then on this side is a backplane so that we could install different types of devices. And so this is a card that has an expansion slot, and it has a chip called Slot Maker, which has one of the signals we need for the keyboard, which is this board. And then this board is another RP2040, which basically interfaces a USB keyboard onto the Apple II bus. And then there's this board, which is a disk drive board, or IWM, which is the integrated WAS machine, which came out of an Apple II GS, or it's in the Apple IIc. So this, assuming this still works, which is what I'm trying to do right now, is make sure this will still boot. This is a fully compatible Apple IIe. Now, the difference between an E, though, is that it doesn't normally have an IWM. And so my long-term goal is to modify this ROM so that the IWM will talk to hard drives, or it's called smart port devices. So this is a project we worked on for about 2 years. The third version is a single PCB that integrates all this into one board, and I'm still finishing that part of the project up. That one has some issues, though, unfortunately. That is going to require a 4th revision, but that's part of what I want to figure out is how can I basically need to figure out how to get to a higher, I need to see if we can get bank swapping to work correctly. Okay, so the next thing I need is a VGA, or what do you call it? Not VGA. Yeah, VGA adapter. So where is... Don't see it. Or is that what this is? Okay. I don't think I've ever used this one. Yeah, I don't know if this one will work. So the purpose of this project was to find out if, there it is, that's what I'm looking for. Then this cable, and I need my capture device, which I think I have over on the bench, because I've been using it with my scope. Yep. Okay, perfect. And then I don't need this cable either. Even better. So the purpose of this device was to determine whether the Mega 2 was actually a fully functional Apple IIe, because the myth that gets propagated is that the Apple II GS is backward compatible because of this chip. And it actually turns out that's not true. It's backward compatible because the 2GS has all the ROM hooks built into it to act like an Apple II. And its memory controller has all of the soft switches to act like an Apple II. So the Mega actually is just an I/O controller, which does have a little bit of backward compatibility associated with it, but it's not why the 2GS is backward compatible. And so the theory I had that I wanted to test was the Mega 2 actually a functional Apple II? And it turns out it is. So we'll go here. All right. Yeah, I don't know. That's kind of... I mean, technically the Apple II does have a GPU. It's just not a... I mean, it's 7400 series logic, but it still processes graphics. Okay. So that's plugged in, that's hooked up. So I guess we can come over to OBS on the laptop. And I think I will leave the camera on the Mega 2 in case something goes explodey. Oh, I need the keyboard. Almost forgot the keyboard. Let's pull out my USB keyboard. We'll plug this in. Now, if I recall, this keyboard interface actually has some problems, or I fixed them. I can't remember. But I think the RP2040 on this particular board is not soldered well. This is not what I want. Maybe untitled. This is what I want. And then display video capture. Oh, this isn't plugged in. That's funny. That's not going to work. Oh, come on. Come on, OBS. All right. So we have HDMI. I don't trust you. I don't think it's working. Have I made my own IC? No. I was looking at, there's a guy that has a, cool. Okay, so that's working now. That has a course where he teaches you how to do an ASIC design, and then using the carrier program from Google, you can get a chip fabricated. But I haven't thought of anything interesting to make that would fit in the requirements or the capabilities. Okay, so hold on to your butts. Let's see what happens when we turn this on. Let me double check the polarity one more time. Okay, I'm satisfied. Master on. It's drawing too much current. Okay. Okay, let's do 350 milliamps. 350 milliamps and see how that goes. Master on. I don't want to. Okay, you know what I'm going to do? Now I'm nervous. So I'm going to disconnect the USB keyboard and the floppy EMU because those are pretty high current devices. Let me see if we're still current. Okay. We're on, but I don't have video. Interesting. Okay. So, and that is, okay, so that's drawing 250. Yes, yeah, so we actually do need about 500 milliamps of current. So let me bump up my supply to 500. And then, because the keyboard draws about 100 milliamps. So, and then I think the floppy EMU probably draws another 50 or 60 milliamps, especially with that OLED. All right, so that's on. Okay, so something's up because the floppy EMU is loading. But I have no video. The video board is powered. Oh, darn, that's why. I lost this signal again. I hate this signal. Well, actually, I love this signal. I just hate this connection. There we go. Oh, this is so cool. Okay, so that's not what I wanted. So there we go. Interesting that we are booting, but the disk drive, okay, whatever. So let me do a control, let me think. Wait, I don't remember. Oh, the keyboard didn't come up. Huh. Okay. Let me. Interesting. Interesting. Something's wrong. I don't know what's going on. Because the keyboard is acting the LED isn't white. It's like a weird color. Let's try this. And it's not getting initialized, which is problematic. So I wonder if there's something wrong with that board. Yeah, actually, Casper, that's more or less why I wanted to hook this up, because I need to figure out, I need to get it running anyway. But, so let me see. Does this reset? Oh, yeah. Okay. So the RP2040 is definitely not running. I think actually, now I think about it, hold on. Oh, you know what? I think I'm an idiot. You know what? I'm an idiot. You know, I just realized this is a total facepalm moment. Where's it at? So I just remembered the keyboard interface doesn't have power. That's what the problem is. Oh, I forgot. The keyboard board, I love that phrase. The keyboard board, which is this one, I designed it without a connection to 5-volt power. And so it doesn't power up on its own. I totally forgot this. So what this means is, do I have my keyboard adapter down here? Because I could totally use it today. That would be very, very cute. No, it's upstairs. Okay, bummer, because I could actually use it right now. No worries. Okay, so we got to apply power to here. And then we'll snake. I'm just going to go right through here. Snake this around. You know what's funny, Casper? I almost wore that shirt today. Like I was looking at it, I was like, Okay. RP2040 is up. We're cool. And the keyboard is initialized. Now when I power on, the disk drive still isn't working, which worries me. But I am able to, it looks like the keyboard is going to work. Nope, that's not what I wanted. I want it full screen. So, nope, this way. Hello, 20, go to 10, run, 20, go to 10. Oh, you know what? I know what's going on. Print, hello, run. Yay!
And there was much rejoicing.
Yay! Hey, Silent. Yeah, a couple of months ago, I removed myself from the affiliate program so that I can dual stream to both YouTube and Twitch. It is so fast, raw computing power, totally agree. Okay, so now we can focus on what's going on with the disk drive. So let me load up my normal disk, and I tell you what, let's just do a PR number. Oh man, I lost my video. This is, I'm gonna have to solder something. This is not an acceptable situation. Okay. Ah. All right. Let's try this again. There we go. Got my video back. So basically, what's going on is the Mega 2 outputs a bit stream of RGB value, of basically a 4-bit value for each pixel on the screen. And the signal I'm clipping to is called window, and it basically tells it, the Mega asserts that whenever we're in vertical blanking. And so the RP2040 is consuming the data as it comes out of the Mega 2 at 14 megahertz. And then we use the vertical blank signal to frame the signal, the information that's coming out. And so every time I lose the window signal, I lose the video. Okay, so PR6 should boot from the disk drive. And it's trying to read the drive, but it is not being successful. That's frustrating. I'm dual streaming to add-ons. Nothing I do on streams are related to Element 14 today. So the last couple of streams, it's been about an equal number of people on Twitch and YouTube. What's interesting, and I noticed this, I remember this from a couple of years ago when I used to do it too, is I think YouTube tends to get a pretty large, a lot of people follow at the beginning because I think the notification goes out and then it always has a drop off. Whereas Twitch is the exact opposite, is that the viewership goes up during the stream every time. So it's really weird because they almost like crisscross over time. Okay, so what is going on with our disk drive? So theory 1 is I have not actually hooked up. Let me think. Okay, I have an idea what I might have done. So let me turn off power and let's go back to the overhead while I pull this apart because I've got to take the card out. I think I have, there we go. Let me look at my jumpers, because that might be what's going on. Nope, I have it enabled as 1. That's the header. Oh, man. I don't remember how to use this card. Okay, I think if I do this, this will work. Let's see, where was pin 1 on here? I don't remember which is pin 1 on. Why didn't I mark pin 1? That was stupid. Okay, I gotta go look it up on KiCad because I don't know where it's at. So we're gonna go open. I think I know how to hook up the ribbon cable, but I don't want to do it wrong because it can cause problems. If it was a real disk drive, it would kill the disk drive, which is not a good thing. So files. So since you try to do topic silent, we are I'm basically trying to get the Mega IIe Rev 2 working again. So this was the project we did for about 2 years, and a year ago we were getting this up and running. I'm working on the video for it, and I've got to go back and reshoot some stuff, but I've got to get the development board to work again. So this is actually working out because, yeah, it looks like it's not, I've got some literal and figurative dust to blow off because I don't remember how this works. Okay, so pin 1 is ground. Okay, that's why I didn't mark it, because it's pretty obvious. Let me double check one more thing. Yeah, okay. So pin 1 is way up here. So if I plug this into here, and then come to here, you can plug this back in. Now, once we get this up and running, then we'll hook up the logic analyzer because I want to be able to look at the address bus while I throw some soft switches. I want to see what happens. Okay, let's give that a shot. Let's see. So what I'll do now is maybe I'll do this so that you guys understand what I'm looking at. There we go. So we'll power on. Yeah, so the problem is it's trying to read, but it's not being successful for some reason. Okay, so I know what we're going to do. I have a feeling I know what the problem is. There's a couple of jumpers on this IWM board that you have to set, but I don't remember how to set them. However, I do know if we go look at the Rev 3 board, I can figure out where I tied all of the signals so that I can set the jumpers. Hey, D3 Jake. Okay. So let's take this board back out because I need to look at it. God, I hate these. I really wish I'd done edge connectors. This would be so much cleaner. Let me try one thing real quick. If I do this. Yeah, okay. It never fails. All right. I might put some deoxit on this just to hopefully make this like a little more slippery. Wonder if that would work. All right. Okay, so got the board. Now I can open up Rev 3. So we'll go open project, KiCad Rev 3. And we'll go look at its schematic. Is the backplane close to an Apple II backplane? Not at all. So that is a common, I feel like it's a common misconception, is that it's meant to be like a traditional backplane or an S100 bus. It's not. The entire design was so that I could get address and data, the control signals, and a handful of signals I cared about, like the case select signals, to all of the cards. The way it's laid out is it's entirely so that we can plug a digital discovery onto the end of it. And so it's actually a really bad layout for cards. It's pretty messy. But it's not meant to be it wasn't meant to be a general purpose slot backplane. It's meant to be a development backplane. So I can plug in other devices that eventually became, so like this is the schematic for the Rev 3 board, which combines all of the hardware we're looking at onto a single PCB. So here I need to go find the IWM. It's this one. And I want to look at its thing. Okay. Well, this is not helpful. This is this is the same thing I have on the other schematic. That doesn't tell me anything. What the? Okay. Well then. You should do it, Casper. Okay, so this says pin 17. Okay, so this is telling me that pin 9 and whatever. Okay, so let's do this. So if this is correct, then that should be, wait, is this an IWM? Okay. So well, crap. Now what I got to do is go get the Rev 3 board and see how it's jumpered, because I don't know how to set these jumpers. I never figured it out. I just played with them until it worked. Okay, so since I've mentioned it 100 times now, I'll tease it. So this is the Rev 3 board. So this is basically everything that's on this backplane system on a single PCB. So, let's see. So pin 9, I have set to nothing. So we'll just leave that one open. Okay, so that's how this one is. Okay. And then pin 17 is set to number 2. Okay. I don't actually know what that means. And then pin 14, which I don't have access to. Why would I do that? Huh. So, wait a minute. Jumper 8 is 14, and that one is set to 1. Interesting. And jumper, well, that's okay. So, okay. So now I do need to go look at the PCB design, because I'm not confident I know what I did. Yeah, I did a number. So Rev 3 we worked on around July or August. I'm looking forward to editing that section of the streams, because I was pissed off almost constantly. Rev 3 has a lot, the EEPROM had a lot of problems. I wired it wrong on the board, and the EEPROMs that I was getting, that I got, most of them are bad. And so it just made for a super frustrating turn on. Okay, so on my board, I have J9, or let's see, or J4 is set to nothing, and that's pin 9. J7 is pin 17, and that is set to number 2. Well, that's not what I have. Okay. That might be what my problem was. And then I have this one. Okay, let's try this. I think that's what the problem was. So, and I've actually played a lot of Where in the USA is Carmen Sandiego on the Rev 3 for really no other reason than it's just a fun game. Well, let me rephrase. It's a fun game when you realize you can just look everything up on Wikipedia. I mean, it's not like it's cheating because you're supposed to look it up in a encyclopedia, I guess, or like an atlas or something. But it's actually pretty fun. And it's interesting how there's some what I will call dated references in the game, just to be polite. So, hey, GB, good to see you. Yeah, so I considered doing a 4th revision of the board way back when, and then I decided not to. But as I look more and more how to enable smart port code, I'm pretty sure we're going to have to... that's weird. Oh, that's why. Okay. I'm pretty sure we're going to have to spin the board because I need one more address line that I didn't connect. All right. Nope, not even close. It's like it's not even trying. Yeah, actually, this time it's not even trying. Wonder what's up. Huh. I gotta say, this is really frustrating. Let's see. Let's go to, I want to look at the slot maker board. Is that IO or proto card? I think it's IO. Nah, that's fine. I'm going to throw it all away anyway. Okay, so, okay. But I want the PCB. I want to make sure I'm connected to the right signal. Hey, 48K RAM, good to see you. Back then would it have been Encarta? Was Encarta no, it would have been Compton's Encyclopedia because it would all be it would have been paper-based. Was there ever a paper-based Encarta? Okay, so that header is the right header. Okay, darn it. I was hoping I was like on the wrong signal. I don't get it then. Am I forgetting something? You know what I just thought of? What if this ROM is the wrong ROM? Oh, we're not booting. That's the problem. Huh. Okay, make sure yeah, so we're not booting anymore. Well, there's your problem. Okay, step one, let's take the card out. And you just jiggle this, because sometimes that one is the problem. Yeah, we're locked up. Okay. Who ruined the bus? Hmm. 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 Our slot maker signals are all still connected. This is connected. Yeah, okay, that's why I did it that way. Yeah, that makes sense. Okay. I'm going to reset the keyboard controller. Maybe. And turn this on again. Yeah, that is not a good thing to be at. So what in the world did I do? Farts. Well, I guess we'll be hooking the logic analyzer up a little sooner than I expected. Oh, how about that? That was a bad connection. That's annoying. All right. Okay. Okay. So what I was going to double check. Makes me wonder. Makes me wonder. I was thinking in part of, for some reason I was thinking Compton's, but I might have that wrong. Electronics being frustrating? Never. That would never happen. Oh, that sucks up 48K. If you need a 2GS power supply, I have plenty. I have plenty. Okay, so how do we get into the monitor? What is that? Call 151. And then I want to look at C500 to C5FF. That's not how that works. How do you do C500? All right, so C4FF. That is not the right code. What's at C600? So C600, okay, maybe it is, because okay, I was thinking of the 2C. So that's right. So that is the disk2 code. Okay. Well, I'm going to plug the board back in because I have a feeling we had a connection problem just a minute ago. Whether that was our actual problem, I don't know. But it was a problem for sure. Okay, so IWM is back into its home. We'll power on. We're locked up. So then I will just play with the cards again, which is a very scary yeah, I really don't like that's happening. Okay, so we are definitely just not even trying. Well, that's interesting. Where did all that? Oh, we did start to try to read the disk. What the hell is going on? Okay. And now we're locked up. So something is trashing the bus. Wow. Okay. And I'm not sure who. So here's what I think I want to do. I think I want to take a step. Well, it can't be. It's not ROM related. Okay, it's not. Well, it could still be ROM related, but that behavior is unacceptable because it. What am I sitting on? Okay. I'm realizing the boards are not fully seated, so maybe we have just a seating problem. Bummer. I don't get it. All right, I'm going to try PR6 and see what happens. So it's definitely the IWM for some reason is not talking to the disk drive, but I don't know why. Now, what I'm wondering is, should we go ahead and reprogram the ROM? Because maybe I do have one of the hacked versions that I was trying to make work. So let's do that. Let's back up and make sure that this ROM is what I think it is. So let me grab the EEPROM programmer. I don't think this is the problem, but I'm not confident because the last time I was working on this, I kept trying to figure out how to shove Apple IIc code into the ROM, and I don't know what state I left it in. Because if we're using the 2C dist2 code, then that could be part of why we're failing. But I really don't think that's what's going on. So we'll power that off. I will take Mr. ROM out from here. Actually, I'll place him on top of the programmer for the moment because we got to load up the software first. GQ. Take them out. Take the cards out and blow on them. Yeah, I might pull them all out and actually spray the connectors with deoxit because it'll help lubricate the pins. And then that should help make them come in and out of the sockets easier, because that is one issue with using the pin headers is the cards do not want to come out at all. Please download new software. Nah, pass. All right. So what do I have? I have a device list. This is a generic. It's a. Is it a WC? Does that sound right? Yeah, WC 512. Yeah, okay. So now we can plug this into the EEPROM programmer. So I have one of these GQ whatevers, one of these, and I thought these could program gals, but they can't. So I've had to buy. I bought another EEPROM programmer that does gals. The whatever T42 or whatever, but it won't be here for a couple of weeks, which I'm going to need a gal for what I'm ultimately going to do is we're going to make a ROM card that plugs into this slot, which contains the ROM that I eventually want to put into the Rev 4 ROM. Okay, so try and smart. See, that's what I'm thinking. I think I've programmed this with, well, that might have been, yeah, I think I did. So let's see, more 2E, enhanced work. Mega IIe Rev 2 working dump. Okay, let's start with that one. And let's go ID check, erase, write, and verify. Okay, connection lost. No, it's not. No, do not continue. How was the connection lost? No. Okay, let's not do it. And well, I wonder what happened. Oh, all connections that wander are lost. You know what's funny about that 48K RAM? In jitter terms, wander is the term for jitter below 10 hertz. Okay, so this is failing. All right, I don't know what's going on. We're going to, I hope this EEPROM survives. Yeah, I don't know what happened. Okay, let's try this. Instead of plugging into the hub, I plugged directly into my laptop. Did not get a response. Okay, let's try this now. Okay, put the ROM back in. I will go and open, and for some reason, I don't like doing it from the file menu. I don't remember why. For something about the recent ones don't always work. So we want to do an erase, a write, and then a verify. That seemed a little quick. All right, so I'm going to read. And then I'm just going to go look at this buffer real quick. So 4C, 13C, that sounds familiar. And if we go down to 600, we should see A220AO, and we do. Okay. I am starting to worry that I know the hex codes of the Apple II ROM a little too well. It's starting to get scary. The TL8662 programmer. So that's what I was going to buy. But then when I went to the site of the company that originally made it, they said that they stopped producing those and replaced them with a new model. And so all of the 866 out there right now are probably clones. And so I ended up buying the replacement, which I think is now called the T42, from their AliExpress store. So it just seems like it's something that lots of people have had bad experiences with. Okay, where the heck is pin 1? I don't remember now. Does anyone remember if that's where I put the ROM before? I think that's how that goes, but I'm going to look at the board real quick. I don't trust. I have already forgotten so much stuff that I would have thought I would never forget, that I'm not going to trust my memory on anything. I think that's how that chip goes, though. I think pin 1 is towards the lever. It is not. What? It is. It is. Okay. Okay. Cool. Hold on to your butts. I'm gonna turn on power, and nope. That is definitely not the problem. Shoot. Are we booting? And we are booting, and we're back to an older ROM because I hadn't changed the name yet, which turns out was a big problem. There's 2 places that Apple II shows up in the ROM, and if you change one of them, it breaks things like ProDOS. Whoops. You know, Uh, um, the new ones can't do higher voltage chips. Interesting. I'll have to look into that because I don't know that I'll ever run into a problem, but yeah. Okay, so crap. I guess what I should check is, can we Control Delete? No. Okay. That's actually a, oh yeah, we can. Okay. Okay. And if I go into the monitor and we look at C5FF, that's, I don't remember all of the code, but I know that that first line, that's the right code. So, So there's something wrong on the IWM board then that is preventing us from talking to the disk drive. But I don't know what. Anything above a 12-volt erase? Okay. That's good to know, though. Or 12-volt, right? Yeah, or anything above 12 volts. Okay. Or anything that requires 12 volts for programming or erasing, not that they would be 12-volt devices. Poop. So one thing I could do is swap IWM chips and see if I've blown this IWM. The other thing I could do is just not worry about it right now because this doesn't really matter. The other thing we could do is I could plug in a disk 2 card into the slot and just boot it from that, but I don't want to do that. That's silly. That's silly. Silly, silly, silly. And then yeah, that's not working. 2732 ROMs? Whoa. I didn't realize they programmed at such a high voltage. Wow, I'm glad you guys are telling me that because I probably would have figured it out, but save me the time of figuring it out. Okay, so why you no want to work? What is your problem? What are you so mad about? I'm looking at the board. I'm making sure slot maker is connected correctly. He looks correct. I have int dev 6 connected. Was there something else I'm missing? Yeah, I mean, I think from that perspective, actually, that's the right perspective is, would you even use an EEPROM anymore? You're probably going to be using an electrically erasable anyway, which I guess now I realize it's kind of silly to talk about the EEPROMs and erase since you erase them with light and not electricity, but whatever. Details. Okay, so crap. I don't know what to do. I'm not sure about our next step. God, these are so hard to get out. Okay. One just step we're going to try real quick. I'm going to see if the connector is what we're talking to now, just to verify that I haven't. Because if no device shows up on one, I don't think the auto boot code knows what to do. But really don't think it's a code problem. Yeah, so that's not even trying. Okay. So we're definitely on the header then. Okay. Okay, so why would this be giving me problems? What could okay, at this point I am going to swap the IWMs because I'm kind of out of ideas of what could be broken. Yeah, let's try that because that's what I'm down to. Which, if this fail, or if this is if the IWM is bad, then I feel bad because I told XOT that I had a spare IWM, and now I may not. Okie dokie. Let's try let's see, what am I looking for? I need, think. Retro computer bits. Where's that box at? Because there it is. Because that has the thingy-mabobber in it. Okay, so we'll pop. So I'm going to. Why is that not popping? I hate using this thing. Come on. Arr, I don't know how to use a PLCC popper. I actually ruined one of my Megas doing it wrong. Well, it still works, but one of the ground pins is bad now, which is unfortunate because there's only two. So I thought you just kind of hook this in. Like I thought I would put it right here. And then maybe you go in like this. Then I thought you just squeeze, and then as you squeeze, it pops out. But I'm not getting the pop. So I'm doing something wrong. Screw it. I'll just pull it up. Like, I have gotten it to work before. but today it's not working. Like, I've gotten it to work really well for everything except for the Mega. Like, this style, just, yeah, it's terrible. Great. Screw it. It's going to be strong enough. No. Maybe this. Yeah, I don't like that either. Well, they only fit into those two corners. I can't. They're the other. So these two corners have the hooks. These two, I can't. The things don't fit in. Oh, wait, I just heard it click. There it goes. I don't know what I did. Okay, so did I hear that click? Yep. Yeah, I don't know what it is. I pressed down on it and then I heard a click and then it popped right out. So whatever. I'm not in the mood to argue with it. All right, so pin 1, it goes up here. All right. Yep, multiple verification. Okay, let's throw that back in and see what happens. Okay, I don't care about these cables anymore. So let's try. Let's see, what do I want? Oh, it goes this way. That's what I was confused. You know, I am going to do the deoxit real quick because I really don't like the way this feels. In fact, I might even spray the fader stuff. Oh, I don't know where it's at. This is D5. So I'm going to try my D5 now that I have. So this may have been provided to me by Keg. I don't know if this is the bottle I bought or the one they sent me. They sent me a bunch of deoxit stuff a while ago. Oh, come on. So this was a suggestion from someone on the YouTube video. This is the top to a compressed air, and it replaced the always leak that was originally on here. So, okay. Now in this case, I'm not as worried about cleaning this connection. I want the oil to lubricate so that maybe this will come in and out of the slot easier. Or the socket, I should say. They're not slots. All right, whatever. Okay. Okay. Let's see what happens. I'm wrecking chips on the Amiga. Yeah. Yeah, I scratched the hell out of... I think all of my Mega 2s have a scratch from that puller. And like I said, I messed up the pins on one of them. It's workable. It's just that one of the ground pins is completely missing now. So unfortunate. Okay, so first up, make sure the keyboard controller comes up because without that, we will crash. And I will look at this and make sure it is caps on, so I know that the keyboard is initialized. Okay, and then I will turn on the power. And no difference. Okay, so WTF. Actually, this time I think we're missing int dev6 because we're not even flashing. That's frustrating. Nope, we crashed. Wonder why. Yeah, something's wrong. God. You know, I don't remember this Rev 2 being so temperamental. I mean, it's really wonder. Nope. What in the world is causing so much trouble? I'm almost tempted to go back to one of the keyboard revisions that I know caused problems before, because I'm not convinced yet that it's not the keyboard interface. Hmm. Well, if you don't have a stable development platform, it makes debugging a little more troublesome. You know what I'm saying? Maybe we will just... Okay, so first what I'm going to do is I'm going to remove the IWM because maybe it's what's breaking things. I don't know. So let's verify that that is not what is causing us trouble. Are you kidding me? Oh, don't tell me this board is messed up. Does it really hate the deoxit? I'm going to plug it into a different slot and see what happens. Okay, so now we're back to where we were a minute ago. What? What? When did you try to load ProDOS? I didn't see that. Yeah, you liar. You didn't try. Hmm. Okay. Okay. I have no idea what's going on. But I'm very frustrated that this is so unstable. See, the thing is, how did it get to unable to load ProDOS? Is that... I don't think that's in the ROM anywhere. So did it actually read the first track? Or maybe that was from the ROM. Maybe my ROM has it. I don't know. gosh, I don't remember why. What did I do before? Yeah, I don't know what to do now. So what is wrong with you? Okay. I wonder if we should just plug in the logic analyzer just to terminate the other end of that backplane. Let's do that. Where is my logic analyzer? It is not in there. Okay. Is it in the Game Gear box? Yep. Okay. So disconnect this. Unfortunately, I need this cable. I don't think I have a second one. Let's see if I do. No. No, I do not. Shoot. Oh well, it's only a few signals. It'll be fine. Okay. So I think what we'll do is let's just plug this in, and then I will connect clocks and stuff because we can't really probe too much without the clock signals. But I don't remember which pins go to which. Okay. So that's earlier I was talking about how I designed the backplane, and this was how the backplane was designed to be. So this is the digital discovery. I designed it to plug directly into the backplane so that we get, from that connector, I get address and data, and then these flying leads will then plug into these other two headers for various control signals that we want to look at. It only the IO or the bus runs at, part of the bus runs at 1 megahertz, part of it runs at 2 megahertz. However, the buffers from my modern devices has a much faster rise time than the Mega II's logic. In fact, that was one of the things I wanted to measure at some point, because I think just by looking at the rise time, we can tell whether one of my cards is driving the bus or if the Mega II is driving the bus. I think. Doesn't really matter. It just would be an interesting way to tell who's doing what. So I'm less worried about reflections and just more thinking that we're picking up noise or something. So I guess going into a high impedance input on the logic analyzer doesn't really solve that, but it's better than zero impedance or infinite impedance. That's just my thought. I just remember a long time ago, and this was before we fully understood how to drive the data bus. Like it wouldn't even, there was a period of time where this thing wouldn't even boot unless the logic analyzer was attached. And then there was a period of time where the logic analyzer had to be programmed or it wouldn't boot. Meaning, like, just passively sitting on the bus, like it is right now, would actually cause the boot to fail. I don't think my hub is working. Because it keeps, nothing is talking to it. Come on, what's going on? Okay, whatever. Let's do this. Oh, the finished board? Oh, I had it out a minute ago. I don't know where I put it. But I think the problem before was just that I wasn't driving like one of the data. We weren't driving the data bus correctly. And so I think the additional capacitance of the logic analyzer just being attached was enough to prevent it from booting. That's sort of my half-assed attempt at explaining what I think happened. I don't know. Okay. Okay. I did not expect this to be so temperamental. I really had this mistaken thought that I was going to plug it all in and we'd be up and running and making measurements, but that is not apparently the case today. All right, so logic analyzer is attached. I just want to see if that changes the behavior, because as I was saying, that was something that I saw before, so I'm just curious if it changes the behavior now. It does not appear to have. So we still have flashy. So this says it's trying to access, and this says it's still at track 0. So the IWM is not causing the disk drive to seek, which is suspicious. Very suspicious. Very suspicious. Okay, so let's do this. Where did the waveforms go? Did I close it? Whoops. Okay, so let's open up an old project because it has all of my stuff already configured. Maybe we'll start here. Okay, if I just run this right now, what do we get? Or what are we triggering on? Rising of reset. Oh, that's not going to ever happen. Let's run. Okay. So if the address bus is decoding correctly, we are spinning around a 0 page, which okay. Interesting. So let's do a protocol trigger on address and try and catch FA62. So if I do a single and then I do Control-Alt-Delete, lies. Okay. So I think this still has the bug that I figured out much later on in time, that we actually have to reverse the so 0100 0110 0101 1111. So what is this? This is 465A. Let me make sure we are running. Yeah. Right. So that should still be jumping to the reset vector. There's some kind of bug with the way that the I don't know what the problem is. For some reason, the pattern recognizer does not work correctly, and I think it has to. Oh, maybe this is what it was. I think it has to do with the fact that the bits are in the wrong order. In fact, it's not just backward. Now I remember. Um, um, Geek Bozu actually had a script, or maybe he did it manually, where I think we we figured out how to decode the address. Okay, that's fine. I'll just attach reset. So which pin does reset want? Pin 24. Okay. So we'll power down. But basically, the pattern trigger doesn't follow the grouping that I created for the address bus for whatever reason. And so you have to change it. And it's not, I think it's actually a problem in the beta version that I'm using, but I'm not sure. I don't know. Okay, so that I think is reset. And then where was phase 0? That'll be a good one to have, is 25. That should be enough for us to figure out what's going on. So now where's phase 0? Ah, James. Oh, I know what I could do. So phase 0 is over there. Okay. So this is phase 0. And then let's connect this ground just so that we get more ground connections. Although we got a pretty solid ground as it is. One of the problems with the digital discovery is its threshold is set to 1.8 volts, which is unfortunate because there's sometimes noise on the bus that shows up as logic, even though it's not, but oh well. Okay, so now we'll come back over here. Item number 1, make sure we're booting. We are trying to boot. So let's do a quick run. Oh, I gotta change my trigger back to simple. Let's just do a run and see if we get the same thing we got before. Yeah, so looks like we're still jumping around, assuming that this is correct. Now, if I do a rising edge on reset and arm it, and then do my control delete. What? How did that not? Okay. Uh-oh. That's very annoying. Control delete is supposed to yank the reset line. I wonder why it's not. Huh, whatever. Okay, so the reason I wanted to do this is because now I have confidence that we're sampling the address bus correctly, because a bunch of crap happens when the 6502 turns on, and then it fetches FFFC, FFFD, which this ROM contains FA62. So we then fetch from FA62, which I think is another jump to somewhere else. So long story short, what this tells me is the address bus is decoding correctly and the data bus is decoding correctly. So that's all that really matters here. So let me do a save as before I forget. Good point. Yeah, FFF could be. Good point. So we can, I know what we can do then. Valid. Okay, so let's do, you know what? Let's just create a new directory because I want to do rev2 revisit it. Okay, and then I'm going to call this why no disk boot. All right, so we should be able to see a jump to the C space at some point. So CO51 That is a soft switch. Text page is a soft switch, and then set text, and then there should be a home at some point. Text set. So this gives me a little more confidence that the address bus is correct, because the soft switches, I don't remember the exact order that the boot ROM goes through, but these seem reasonable. So soft switches are basically hardware that's inside the Mega 2, or in the case of the in the case of the Apple IIe, they're inside of the MMU or IOU, I forget which one. But their addresses at C00 to blah, blah, blah. Like I think CFF? No. C0XX are the soft switches. And so what this means is the processor does usually a load or a I guess it can do a write because some of them are write. But anyway, whenever the Mega 2 sees this address, C051, it changes the way that it does its video. So in this case, it's, I think text set is, it's putting the Mega 2 into text mode. And then these F stuff, the F stuff is yeah, no, this should be working. Hey, Baloo, how you doing? It's been a while. Data bus looks like multiple chips are trying to drive. Yeah, that happens. That actually does happen. What ends up happening on so what may not be obvious in the Apple II design is there's two phases. Well, the 6502 in general, but so on phase 0, on the falling edge, there is it's the video, and on the rising edge is data. And so that's why I said earlier the backplane is running mostly at 1 megahertz, but the memory side is running at 2 megahertz because the RAM is actually being accessed on both edges of the 1 megahertz clock. And so the first access is for video stuff, and then the second access is for whatever the 6502 is doing. So in general, what you'll see happen is if we get far enough into the code, you'll actually see where the Mega 2 is refreshing the RAM automatically. So anyway, so that's what's going on the data bus is even though the address is only latched for one cycle of phase 0, we see two phases of data because there's the video phase and then the data phase. So here we jump to slot 2 for some reason. I don't know why it's doing anything in slot 2. I'll have to go look at that someday. Okay, and then we run out of space. Okay, so okay, the next thing I'm going to do is let's hook the logic analyzer up to the int-dev6 so that we can hopefully see when the disk drive is getting accessed. So how can I do that? I need a jumper wire. What do I have? I need a stick to a socket. Is this gonna be long enough? And then I want like number 27. I might be able to make this work. Okay, so we're powered off. So I'm gonna move this down to here. And then we'll plug this into here. Suspicious. There we go. Okay. So we'll power back up. And we are booting. Okay. Or I should say we're trying to boot. Okay. So now what did I say? What number did I give that? 27. So on here, I probably have, we're going to change this to be int6. And int in this case is not interrupt, it's internal device 6, because the slot maker chip from the 2GS as it maps between internal devices and external slots. And so since the 2GS has most of its hardware built into the board, slot maker defaults to its internal devices. And so int dev 6 is basically just the enable signal for what would have been slot 6, which is normally where people would put a floppy drive card, or the disk 2 card. So that's why I'm interested in what that signal is doing, because that's when I have no idea what I just did. Shoot. Okay. Let us reopen. Do you want to save? No. I think I added the signal to the address bus by accident. Okay. Int dev 6. Save. Yeah, that's what I did. Okay, let's put this up here. And then let's put that put it right around reset. So if we run right now, int dev 6 is probably high. Okay, so now what I want to do is I want the falling edge of int dev 6. Okay. So now let's zoom out a little bit. Okay, and hit run. And I want to get an idea of what it's trying to do right now. C0E6 is not anything I recognize. Interesting. Okay, so now what we're going to do is I'm going to hold this in reset. I want the rising edge of int dev 6, because then that'll be after it's done. It's been, yeah, whatever. And then we're going to run this, and I'll release reset. Well, that's, oh, because we're not cold booting. There we go. So we tried to access it multiple times. Yeah, okay, cool. So this does show me kind of what I wanted to see. So, okay. Let's zoom out just a little bit. And then I'm going to reset. Let's do a run, and then I'll PR6 again, which this will probably fail. Yeah. Okay. What I'm basically trying to do is I want to see where we access the slot and then start from there. Because I think this is kind of cool. Well, okay, I'm not going to try that hard. But what's interesting is, so we're in this, so the address bus right now is in C6XX, which means it's reading from what normally would have been the ROM on the card in the slot, but because it's an internal device, it's the ROM it's my ROM. So this is the code, so that it's executing the code that's there. And then eventually slot maker says, hey, I want to talk to, I do wonder why this runs for so long before it actually talks to the disk drive. That's kind of suspicious to me. Memory is driving both data, video and data. Yep. Oh, thanks, Shell Schlock. So E6 is the phase 3 off. Huh. Okay. So if E6 is phase 3 off, then I'll bet like EE may actually be one of the phases on, an EC or something. So interesting. Hey, Blind Via and crew, welcome to the stream. Yeah, actually, I'm glad you shared that page. I can't put it on the stream because I don't have that set up anymore. Why is there somebody at my door? Oh. Hold, please. Anyway, so Blind Via, welcome. Good to see you, man. Hope you're doing well. Hope your stream went well. I'm working on my old Mega 2 project. So this is where we took the Mega 2 chip out of an Apple IIgs and built a Apple IIe compatible computer. And while this system was fully functional the last time I touched it, I can't get it to load the disk drive anymore. So we're kind of looking around trying to get an idea what's going on. Oh, the local alderman. Oh, okay. Okay, one more time. Weird. Wonder why. Whoa, that's annoying. Okay, so. Okay. Hmm. You know, you know, I mean, I know for a fact that this emulator works. However, I also don't know for a fact if it's working. I mean, I just used it the other day, but this looks like it's trying to read from the disk, and for some reason, the IWM is not responding correctly. Oh, very, very frustrating. I wonder if we should, let me think. I wonder if we should go back one more ROM. You know, I'm gonna try flashing the ROM one more time. I don't know. This doesn't feel like a ROM problem though, does it? You know, the other thing I could do is just say screw this and do the measurements that I wanted to look, do the things I wanted to do, because I don't need the disk drive to do what I want to do. It's just really frustrating that I can't now play Carmen Sandiego later. That's just not acceptable, if you ask me. What caused this to happen? Why would this be broken? Was there another signal I was supposed to connect? So I didn't connect the open and closed Apple signals, but that shouldn't cause a problem. Well, the problem is that I need Rev 2 to work because Rev 2 has all the stuff broken out. And so it's much easier for me to put a logic analyzer and oscilloscope onto this system than Rev 3 because Rev 3 is pretty much self-contained. Also, Rev 3, I can't change the ROM because I soldered the ROM to the board and it's been bodged about 1 million times. Give or take a few, it's about 1 million. So I really do need Rev 2 to be functional because I need to, because the whole reason I was keeping this around was for stuff like this, where I want to mess with the ROM or measure some signals or change one of the boards or something. I'm just frustrated because this was a very functional platform not that long ago, and now it's not working at all. So, okay, because I don't know what else to do, so we are going to just reprogram this ROM one more time. I'm kind of at a loss at the moment. I feel like this is I guess the other thing I should do is I should go plug this floppy emu into another computer and make sure it is actually working. So maybe I'll do that. Just as a sanity check. I really wanted this to be somewhere else. And I want you to go away. Hey, Christopher, what happened? I don't know. I don't know what happened. Okay. I mean, this has been sitting on the shelf for 6 or 7 months now. Well, let me think. I did take it to Kansas Fest, and it worked at Kansas Fest. Ooh, that's even more frustrating. So it was working when I went to Kansas Fest, but then I started playing with the SmartPort stuff again. And that's why I was thinking it could be related to the ROM. Son of a... It was just I was using the wrong ROM version. Oh. What time is it? Oh, that's so funny because I was drawing that connection. You know what I ought to do? Let's see if I have. Yeah, let's just rename this file. So which file was this? Golden Delicious ROM images. Apple, let's see, what did I do? Disk code maybe? No. I did this under more enhanced 2E work. I actually wonder, this might still be wrong. All right, and then I load it. Mega IIe disk 2. I'm going to just say copy that. We're going to rename this to this one works, dummy. I better make that a little more obvious. You dummy. There we go. Okay. Well, that was fun. Can't believe that took all day. So let's see. If this is the correct keyboard interface, I should be able to hit tab twice. And I can. Sweet. Okay. Oh, God, this works.bin. Nah, GB, that's too obvious. Come on, we can't do that. That's just silly. Okay, so you know what I want to do now? You know what? Just to see something. On the logic analyzer, I want to still do an intdev6. Where did the logic analyzer go? An intdev6 trigger. So I'm going to hold in reset, hit run, and then release reset. Yeah. So the code is completely different. Okay. It's off in the D space before it accesses the disk drive. which is not what it was doing before. Which is still suspicious to me, but I'm skipping that for now. I actually wonder if we swapped ROMs and or ROM banks and don't realize it. Share your secret wants to invite you to connect. Somehow I think that's spam. Okay, so the whole reason I wanted to do any of this. Okay, so the funny thing is now that the disk drive is working, I can just shut off. I'm going to disconnect the disk drive because I don't want it. Tell you what though, we'll at least do this just to make sure that it actually is working. Oh, this one has the Mega IIe in it. Interesting. So I wonder, actually I do want to check something then. No, let's see. Who checks the magic byte? Merlin might. Oh, this is a Rev B Mega. Huh. Yeah, so unsupported configuration. Yeah, okay. So this ROM is actually not the one I want to be using long term, but we're going to use it today because this one has a mistake. Oh, and that's what that other ROM was, fixed Apple. Ah, okay, whatever. Let's do 3F4, trash that, Control Delete, Control C, or Control Delete. Okay, okay. Rename the file again. Actually, I am going to, because I'm going to be more serious with it this time. So working disk code bad magic apple byte, and we might actually go and fix that so that I have a known working ROM image. But I want to get to the thing I wanted to get to today. So anyway, gosh, I wish I had this on this computer. So why don't I do this? Whoops. HTTP, nope. apple2.guidero.us doki php ng notes general IO page. No. Why didn't that? I wonder what I did wrong. This is what I want. Okay. So this is I actually have a printout of this now I think about it. It doesn't matter, but I've got this printed out. So these are the soft switches that we can go hit. And so like the two that I love the most are C000 and C010 because they're the keyboard soft switches. So as an example, just to demonstrate, if I write a quick basic program that does a print peak from 49168 and then, oh, nope, 10 print peak 49168, 20 go to 10, run. So when I press a key, the value changes. And notice how it will change. I'm going to do this. So it does a couple of things. One is the value is 47, which is the last key I pressed. But once you press a key, the value sets the 8th bit or the high bit, which is what tells the hardware that there is a new key available to press, or that's been pressed. And so C000 and C010 are the magic that the PIO and the RP2040 are dealing with so that the USB keyboard works on the Apple II bus. Anyway, so that's fun. Oh, I had a question mark. Is that why? Okay. But what I'm interested in is number 28, I think. Yes. See, number 28 toggles the ROM bank on the Apple IIc. Wait, and the GS, but only ROMs 1 and 2. Interesting. And then M is the MAC card. Okay. I think this is going to work. So what? Okay, and it's a write. Okay, so if I poke, let's make this bigger. Okay, let's do a home. So if we poke, what's the number? 49192. And then, see, that was stupid because I don't know how to, oh yeah, we just hit it again. Let's go into the monitor. And if we look at C5, well, you know what, let's just try C600. Okay, so that did not change anything. Interesting. Okay. And then what about what's in the D space? Let's try D100. Yeah, let's try D100. So let's go to DFF. All right, and then we'll poke. What is it? 49. All right. Now, we shouldn't see anything change because my ROM does not have address bit 14, which is what this switch should be changing. Oh. Good call. Yeah, okay. Yeah, okay. So what I should do is CO28 and then do, yeah. But the ROM contents we read shouldn't change because even if the address bit is getting set by the Mega, we're not seeing it. So what I want to watch is a couple of things. We want to know when ROM enable is accessed and when bit 14 of the address bus is accessed. That's what I want to know. So I need to hook up ROM enable to the logic analyzer, which is not on anywhere. Okay, that makes this a little bit more difficult. Let's see. Originally, I had it on 26, which is purple. But I think what I did was, I think there's a, yeah, it's over here. Okay. So let's turn off power just to be safe. And then let me grab a extension. Let's go with purple to keep it the same. So I'm going to grab all of this, come up and through here, into here. And then I need another clipper, grabby clipper. And then this will plug into the ROM enable. So what we're going to do is we're going to watch ROM enable. I want to see if ROM enable gets triggered. What do I want to see? I want to see if we change the address bits. That's what I want to see. Okay. power back up. No, try this one. Okay. Control Delete. Do this. Get into the monitor. And then, okay. So we're where we want to be. And now what I want to trigger on is ignore. We don't care about dev 6 anymore. Now I just want to know when ROM enable gets enabled. So let's do a rising edge of that. Well, we'll do the falling edge because that's really what I care about. Okay. The other thing I want to do is the number of samples. Let's do 1 million. So that we can move around quite a bit. All right. So if we do a single right now, I wasn't actually expecting it to trigger. I guess it's because it's sitting in a loop, so it's probably reading the ROM a bunch of times. Let me catch up. Hey, Mike, good to see you. Hey, Louise, welcome back. Kind of missed you guys a minute ago. Apologize for that. Yeah, I guess I'm kind of messed up on my chat today because I have Restream on my monitor in front of me, but the type is too small, so I can't actually do anything. Or I can't see it. Okay. Anyway. Okay, ROM enable is getting access a lot more than I expected. Wonder what's in the C200 space. Hold on. I'm just curious. So let me think. What is the Apple IIe memory map? And I think it's from John something. Yeah, John Relay. This is a great site. He has lots of good information. C100 is the extensions to system monitor. Makes sense. I'm in the monitor, so ROM enable is getting hit. Okay, that's going to complicate things slightly, but we can work with this. We can make it work. Because what I can do now is I want 14 to be high. Okay, when ROM enable transitions. That didn't work either. The problem is I know what I want to do is I want to put the address that we're going to hit. Okay, I got to reduce that sample depth. Let's put that down to like 128. This is suspicious. Is this not combining the two triggers together? Is this an or an and? Let's look at the trigger point again. Because I want it, the falling edge of ROM enable when 14 is high. So it is anding them. Huh. The problem I have with this is I don't think that should have happened. Right? Because if the address is C27F and our address bus is 15, 14, 13, 12, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I can't fix this. So C would be 1010111100. Oh, crap. Wait, hold on. So it's 1010101111001101, right? That's A, B. So this isn't what I thought I needed. The problem... I thought it was bit 14, but it can't be. What did I miss? So let's go look at the Apple IIc schematic real quick, which fortunately now exists in BitPreserve because someone redrew it. Can you believe that? Can you guess who? I'll give you a hint. It was me. Which, okay, so what am I looking for? I want to go look at the ROM. And the ROM, I think, is like in here. So its chip enable is driven by ROM enable. See, I messed up something because then how does it switch to bank the other bank? Because the ROM is not addressed this way. Okay, actually, this... Okay, that's my problem. I'm looking at the 6502's address bus, right? But then how would it do this? I'm confusing myself now. Yeah, I use Linux on a lot of stuff. You think it's not on the address bus? I mean, that's how it was in the schematic, though. What am I thinking of? Reference schematics. To okay. I wonder, now that you say that, RJ, I wonder if that was a later revision. Huh. Okay. I wonder if this is a different version, because there was that really early version of the 2C, and I wonder if this is the earlier version. Because this schematic, which apparently I didn't even copy correctly, grounds address 14. So if somebody else activates that bank, how? Okay, I'll tell you what we're going to do. I'm going to get my 2C board. Hold, please. Apple IIc Where are you? Scooby-Doo. Let's see, that looks like a Macintosh. This looks like an Apple II. That's a box that fell. Where did I put my Apple IIc? Where, oh, where could it be? It's not right here where I thought it was. That is the best song I've ever sang. That looks like a Commodore. I wonder. That's all Mega crap. So that's not it. This is 2G. Oh, here's my. Well, shoot. I thought my 2C was in pieces. It appears it is not. That's not right. I've got to have another one of these. Yeah, this is not the 2C I'm looking for. That's not the 2C either. Or is it? No. Oh, what's this? Nope, that's an Apple II. Well, that's the box of the parts to go to the 2C. Where did I put the 2C at? How could I lose it? It's like my favorite computer. Oh, here it is. Okay. All right. So. Oh, so what am I doing? I want to know where address 14 of the ROM comes from, or goes to, or what it does. So let's turn off the Mega 2. Let's go to here. And I don't think my DMM is running. I don't even know where my DMM is at. Whoops. I'm not going to take the time to power this up, but if it works, we'll use it. If not, I'll just keep it on camera. Okay, so yeah, I don't think it's connected. Okay, so the whole idea here is I want to probe A14 of the 6502, which is 24. So how many pins is this chip? Is it maybe, I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20. So 1, 2, 3, 4. That'll be easy to find. And then on the ROM, it should be pin 27. So let's see. 1, 2, 3, 4. And then ROM is supposed to be, where are we at? UD18 or D18. So there's D and 18. This is the ROM. Okay. So 1, 2, 3, 4, and then 28, 27. Okay. And then let's see. 13 will be 23. So if I come down this one, and 13 on the ROM is 26. So it could be this one. I'll be damned. RJ Helms was right again. Okay. So now I want to know where does address 14 on this ROM go? I see it. It's right there. Okay. So it's there. And then it looks like it goes under here, through here, maybe somewhere over here. Is it one of these? It actually looks like it goes to a pull-up, but I can't verify that. Okay. So then, if it's on the IOU, let's see if we can find it. I think this is the IOU. Okay, let's check the MMU. That's where I would have thought it would be. Okay. I wonder if it goes to the glue chip. It doesn't seem to come from the IOU or the Mega or the MMU. Okay, I don't know where that signal goes. It goes underneath this map chip. I wonder if it's connected to this somewhere. No. What else could it be connected to? Here's the glue. Let me check him. Nope. Okay, I'm going to check the rest of the CPU and just see if I got the wrong pin. I can't find where this is connected. Uh-huh. You little jerk. I found it. So pin 27, let me make sure I have this right. 1, 2, 3, 1, 2, 3, 4, 5, 6. So that's 14. This is 15, 16, 17, 18, 19, 20, 21, 22, 23, 27. Is connected to pin 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 of the CPU. And pin 6 of the CPU is address 4. What? Oh, that's the monitor. That makes no sense. Pin 6 is non-maskable interrupt. I feel like I'm missing something. So there were 3 revisions, major revisions to the Apple IIc ROM. The very first revision was only 16K, but it was pinned for 32K. And then the next release of the ROM was 32K, or 32K and then 64K. Basically, it was designed to be, it was the same size as the IIe in Rev 0, and then Rev 3 doubled the ROM, which is where the bank switching starts to happen. And like, for example, in Rev 3 and 4, there's support added for Slinky memory expansion cards and SmartPort. That's like the 2 significant changes that happened to Rev 3, which is what I'm interested in. So that's why, so I think the schematic I have is for a ROM 0 2C, which is why pin 14 of the ROM chip is grounded. Okay. The W jumpers. So my W1 is closed. What did you say? You're saying no bank switch, W1 closed. So this is my W1. Let me make sure this is. Yep. And is that? Okay. And then where's W2, I wonder? I don't see a W2 unless it's on the other side. No. Okay, W2, shoot, which I would assume. So I don't have a W2, or I just don't see it. But how could I tell? Okay, so let me look up this part number real quick and see which ROM this is. So we're going to go to Apple II A2 Logic A6. A2 Logic. I forgot what the site is. It's like Apple II Logic A6. There we go. Apple Logic. That's what I was looking for. And then if we go to the 2C, so I have a 342. So the ROMs I think are down here. 3420272 alpha. Gosh darn it. So this one doesn't do bank switching, which doesn't seem right because I'm pretty sure this one does smart port just fine. At least I thought it did. I found W3 and 4. I still don't see W2. So, So somehow, somehow this board supports smart port. You know what? I wonder if I never got that. Maybe it doesn't. Huh. Maybe this doesn't work and maybe it doesn't. Well, crud. All right. So let's see. Okay. I tell you what I am going to do before I forget is we're going to just write ROM 0 on this board because I'm going to not remember that and I just want to put a 0 on it. Nice. Okay, whatever. Okay. Darn it. So RJ, you are telling me that it should be connected to pin 7 of the IOU, which is what? Yeah. That's right. That's right. Yeah, who can we blame for getting this wrong? The intern. So Crud. Okay, I think we know the answer to what we've been trying to find, and we don't even have to do any more logic analyzer probing because I drew the ROM 0 schematic, and apparently I did it wrong, so I'll have to go back and fix it later. I didn't make the connection that there was a bit on the IOU chip that did address 14 of the ROM. because there is no equivalent signal on the Mega. I'm pretty familiar with its pinout, and it doesn't have a signal like that that's not used. RAM Bank 0 is not what you think it is. Let me think where I have looked it up multiple times. Well, you know what? I looked it up multiple times and I always dismissed it because I was like, yeah, I don't care about that. So maybe I do care about that. So let me find the document real quick. Here, I'll do it this way instead. I'll put this on the screen because it's more interesting. So RMBK's what is it's BA0. Sometimes we'll find it. So let me try Mega to 2GS RAM Bank 0. I can't remember the RMBK. Technical note. There's a technical note that covers this, and I can't. Okay, I think I found it, or I found the archive, so we'll be able to find it now. So this is not what I was looking for. That's not what I want. The technical note calls it something else, and I can't remember what they call it. It might be MA02 in this document, which is why I can't find my copy of it because MA0. Gosh darn it! I wish I could remember what it's called. We've never checked its behavior though. Okay, you know what? Tell you what. Let's just, for fun, let's just hook up a logic analyzer to it and see what it does. Because I'm pretty sure I have it broken out. I do. So let's just look at it on the logic analyzer and see what it does. Why not? Why not? I wonder if I can figure out how to get smart ports shoved into the 2E ROM. I wonder if I can make it work on the 2C. Rev 0. Huh. Anyway, all right. So let's power this guy back up. No. First, we need to hook up the logic analyzer. Mr. Logic Analyzer, I would like number 28, please. And it's got to get all the way over there. That's going to be a long haul. That is a long, long haul. Yeah, fair enough, RJ. I feel like it's something. I feel like the RAM Bank 0 is related to, because I think it's RAM Bank. I don't think it's ROM Bank, but I think it's related to the mirroring of the of Bank E0 and 1 on the 2GS. However, it looks like Gemini supports the soft switch. So if Gemini supports the soft switch, there is a reasonable chance that the Mega 2 does too. Not a great chance, but a reasonable one. All right, so we're going to hook this to here. And then I need another clipper thingy. So we'll take this clipper thing. So for example, I was talking earlier about Rev 2 versus Rev 3. So like these signals that we're looking at are not broken out anywhere on the Rev 3 board because I deemed them unnecessary. So, you know, this is kind of like why I wanted to keep this thing around. was so that I could do this kind of evaluation or investigation. Okay, so let's power up. Make sure we're powered. Looks like we're booting. So let's do a Control-Delete. And we'll get into the monitor. All right, now we will go to the logic analyzer and see which pin did I just hook up. Bit 28. So have I defined bit 28 as anything yet? I did. Read write. Well, we're not going to use read write today. All right, let's move this up here to ROM enable. And this one is going to be RAM bank 0. Okay. So let's just keep the same trigger we have at the moment. That's not a good sign. We should have triggered. Did I lose ROM enable? Yep, that's why we didn't trigger. Okay. Now we did. Okay. There we go. Okay, triggering. Now, let me rearm that because that was a lousy trigger. Yeah, so we should trigger right away because we're constantly hitting the ROM. But basically what I wanted to see is it looks like right now RAM bank 0 is a low. So now what I'm going to do is I'm going to say if it ever transitions, I want to see the trigger. And so if we look at this section, we say we're armed. And so we're basically waiting for something to happen. So now I'm going to do something and see if that triggered anything. It has not triggered yet. Okay, so let's get back into basic and do a little something. All right, still hasn't triggered. Okay, so now what I want to do is let's go ahead and do a reset and see if that causes. So I'm holding the reset button and I'm releasing it. So at this point, what it looks like is RAM bank 0 appears to stay low all the time. Let me stop the analyzer and change this back to don't care because I just want to get a random sample and see that it's 0. Okay, so right now it's staying low. Cool. No, this isn't a Raspberry Pi. It's a, so this is a, so this computer, this is a computer we built using a chip out of the Apple IIgs. So this is actually an Apple IIe that's custom built, that we built it. Okay. Now, so now what I want to try is arm the trigger. And then I'm actually going to take this out of full screen because I want to see when it happens. Let's go windowed. Oh, okay. So in theory, oh, I forgot to do this. Rising edge is fine. Arm that. Okay, let's see what happens when we hit. Let me do a poke to, what was the address? Wake up. 49192. Yep, 49192, comma 1. Nothing. Okay. So let me try C5FF. Okay, that didn't seem to do anything. So now I'm going to try and write to that C switch again, which is, now I'm going to do C028. And 3.5FF. Oh, that's the wrong address. Okay, so whatever that signal is, we're not affecting it. we're gonna try some. I got another one. We're gonna try one more. C029. That's a V. I don't know what V means. Nope. I don't know what I'm typing. Okay. Bummer. Bummer, 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 bummer. I thought that was going to be the magic. So CO28, what I'm noticing on the, let me see, did I still have this open? So what I was noticing on this switches page, so CO28 is the one we've been hitting. That doesn't seem to be doing anything. So then I thought maybe, oh, wait. Okay, hold on. I was looking in the wrong place. So CO28, let's try D00. All right, C028, D00. No, that's not toggling it either. Okay, so I thought maybe that would do it. So C28, which is the one that is in the 2C. But what I noticed was the 2E, the PDS card, which is the Gemini chip, it has main and aux ROM, which is more or less what I'm trying to do here, is switch to a different ROM. And it had an address for 29, but so that's why I hit 29, but it didn't seem to do anything. Because I was thinking maybe 29 is in the Mega, but yeah. So regardless, even if, so, I mean, that switch might still be doing something, but it's not doing what I want. Am I writing to, yeah, I wrote to 28, yeah. I'm doing it long way now just to make sure. So if I go C28 and then write again, and then let's look at D00 or C3FF, CO28 00, C3FF. Yeah. Oh my God, sorry. I don't know. I guess couldn't really see what I was doing anyway. Doesn't matter. Basically, as I've been changing the addresses or changing the switches and then reading from the addresses, I've been trying to, I've been waiting for the logic analyzer to trigger, and it's not. So it's, yeah. So I don't think that's doing anything, which is very frustrating. Maybe it's ME2B0. Let me try. I just wish I could remember the. Let me look at one more thing. Oh, that's why I did it that way. Let me just search for 2GS. BBL inhibit. I wonder if I could, if I do a search for 1000 bit, will it show me all the notes? No. Nope. That's annoying because that would be, that's what I want. I want to know all of the things from 1000 bit that I have notes on. Okay, VBL. That's not it. Inhibit. That's not it. Apple IIc, Apple IIgs, maybe I can find it in here. DMA, monochrome, reference hardware, Mega II video, VBL, how to run out of memory, the memory manager, slot arbitration, pitfalls. Okay, I was hoping. Gosh, I wish I could remember how they refer to it because it would make this so much easier. Yeah, the CYA would have done the banking because there was no ROM connected to the Mega II. So the CYA would have handled it. Because remember, there's only one ROM in the 2GS, and it's on the CYA side, which is why I always say the Mega 2 wasn't actually used for backward compatibility because it never actually saw any ROM code. It actually didn't even, it never saw any ROM fetches. So it only saw RAM and IO. Darn it. I wish I could, it's so frustrating because I've come across this signal multiple times and I just don't remember. I don't remember what they said about it. So I'll have to go back and look at. But again, I think it referred. I remember it being RAM bank 0, not ROM bank. So I don't think it's and we're hitting the two switches we know about, and it's not doing anything. So poop. Okay, well, shoot. The bad news is this doesn't quite solve the problem I was hoping it would solve. The good news is that that's not good news. This is actually really bad news. Yeah, that's actually what I'm afraid of, RJ. Well, here's the plan I was actually headed down. And this might still work for my computer. Here's my plan. So, even on Rev 3, I have a slot. So, what I was planning to try to do, and this is actually the next card I want to design, I'm going to design a card to plug into the slot, and it will have the smart port code in the expansion ROM space. So C800 to CFFFF, which is where it exists in the 2C code. The bad news is it jumps all over the place. The good news is it's all contained within C883 to CFEF. Beautiful. So I'm going to make an expansion card, and then we'll use the C switch for aux ROM. What am I thinking of? It's this one. So there's a switch to tell the Mega whether we want to talk to the slot ROM or the internal ROM. So what I'm going to do is I'm going to put the IW, I'm going to put the code I want into the slot. And then throw this C switch and jump to the card and then come back. So I think I can do the same thing that the 2C is doing by adding another ROM. Don't fear the bucket of 74 series. Which is why I was going down the whole PLD thing the other day in Discord, because I don't have it on this computer, because there's this whole little this is actually I don't know, I find this interesting, so let me show this really quick. So if you build a card and you use the expansion ROM space, which is what I plan to do, there is this circuit that you have to build, and you basically have to detect when an access to CFFF occurs, which you can do by only looking at 12 of the address bits plus the strobe, and then use a latch to either enable or disable your ROM. Because the way that this works, and this is the really cool part, and this was driving me bonkers trying to figure out what was going on, and it's because I didn't understand what I was doing. So what I'm doing now is I'm opening up the ROM code for the 2C, which I actually put in a whole nother directory. Retro computing, 2C, ROM disassembly, ROM 3, bank 1. We'll start with this one. Maybe I don't want this one. Yeah, I do want this one, because if I go to C500, so C5, so this took me the longest time to realize is the 2C, its boot code is different than the 2E because it's a different machine. Duh. It checks slot 6 to see if there's a bootable disk. It doesn't have to make sure that slot 6 is a smart port device though, because it will never be a smart port device. It can't be in the 2C. So if it can't boot the disk in slots, the built-in disk drive, then it switches to the external port, and that port effectively sits in slot 5 or C500, and then that is where it tries to check to see if there's a smart port device or not. I don't know why, but for some reason I know why, because I forgot that the built-in drive is built in, right? Anyway, so in this code, and I apologize that it is kind of small, but I don't remember how to make this bigger. I don't know why I would apologize. I mean, because it's polite. Let's just make it, I can only go to 20. Okay, that's as big as I can make it. So here's what was thrown, here's what really, where's it at? Yeah, here it is. So basically what happens is, it's like, hey, maybe it's a smart port device. So it wants to run the smart port code. And it was driving me crazy because it would do this load from CFF. I was like, why is it loading from CFF? The reason it does a load from CFF is this circuit. Whenever a card sees an access to that address, it has to disable its expansion ROM, because the idea is that the cards share this one block of memory. So you access the card, it switches in its ROM, and it stays active until another card needs to use that memory space. And so you have to switch the thing in and out, which I think is going to work just fine, because that's exactly what I want to have happen. Now, in the 2C code, it does that, and then it jumps to the second bank. And so basically, I'm going to just change that to, instead of jumping to the second bank, I'm going to enable the C switch for the auxiliary ROM, and then jump to its code. So I think I can patch it in. I really do. we're going to try finding PLD working on a 5-volt or mixed voltage again. So on there's an Apple II Slack, and a couple of guys there have PAL or Gal code that already does this. In fact, one person sent me a schematic and his design file, and it's basically doing what we want to do. In fact, I'm tempted to just design his board because it is, actually, I'll show you. I think I can show you because he said he's going to eventually post it, so I don't think I'm giving anything away. But let me show you what he did, and then you guys are going to be like, yeah, that's what James is going to do. Because originally I was going to make this be a ROM chip that we plug into the board, but this is really clever, and I really like it. Where did I put it? Oh, maybe I did put it in Golden Delicious. Yeah. I don't have the full schematic. Okay, my bad. So he has built a RP2040 card that plugs into the slot that emulates ROM. And so he basically has a circuit where you program the, it has a RAM chip. So you program the RAM from the RP2040, and then it switches into, then it acts like a ROM. Isn't that clever? So I really like that idea because then it's going to make it super easy to iterate through the code. So I might just do what he did and use an RP2040 or a Pico with a RAM to emulate a ROM. I think it's clever. So it'll just be a lot faster and easier than reprogramming the ROM. So yeah. So anyway, I have some gals that I ordered. I ordered a new programmer that supports them, and then we'll start. We'll probably. I was actually going to do that card today, but I wanted to. I need to get this. I needed to get the Mega 2 back up and running because I need to work on the video for it. And so I'm glad I did this because we had to work out the bugs, right? So the good news is Rev 2 is working again. The bad news is that it doesn't bank swap like I was hoping it would. But that's okay. We have a plan B that I think will work. Fortunately, you guys talked me into putting a slot into the Rev 3 board. And so I think this card is just gonna, I'm just gonna put this ROM in. And then my thought is, if this works, I'm probably going to do a Rev 4 and include a ROM on Rev 4 to do all of this. So yeah. This project, the project that Yaros sent me, is a win couple project. And I was trying to use it the other day, and I got so mad at it. So okay, well, that's disappointing, but also kind of cool. All right, let's do something fun. Bum, 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 bum. No. I know it. Oh yeah, let's see if this is working. Let's just make sure. But we need to do a quick check. We need to make sure that. I need to learn how to spell. Come on. Let's go to N number munchers. Okay. All right. And then call delete. Oh, okay. Let's do a poke 12.1. And then control delete. Oh, I don't have the speaker hooked up. Fail. Okay, too bad. Yeah, I don't want to hook it up. Too many efforts. Okay. I haven't played this in months. So let's see what happens. I'm just glad we got it working. Man, I'm so glad. Okay, so... Oh, delay. Do I want instructions? No. Primes. Is 2 a prime number? Oh, man, that's not where I'm at. Dumbass. All right. Oh, 1 is not a prime number. This is not as fun without the sound effects. That should be dun Brump, brump. Brump, 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 brump. Ah. I missed the key press there. It must be the bad code on the ARC 2040. I forgot how to math. Okay, well, that was fun. Cool. So, mixed bag. We sort of had stuff work. I'm really disappointed about this soft switch, though. I was really hoping that we could throw that switch and get another bank. I'm just thinking towards when I build the final board, or the next, Rev 4. So that's Rev 3. Ooh. I really hate the idea of putting a whole nother EEPROM. I don't want to have a gal on that one. Gals draw like 200 milliamps, which is more than, it's about what the Mega draws. Self-made things. Okay, cool. Well, this was fun. There was a new Workbench Wednesdays that came out. If you guys did not catch that, this week was, what was this one? Oh, this was the handheld scope DMM that I showed a couple times on stream. What am I looking for? Baldee latest. So, spoiler, I like it. I was actually surprised at how well it works. I still don't recommend the scope DMMs to be your first oscilloscope, but as a spare to have in your lab, I think it's a good idea. I like them. So, anywho, okay. Well, that was fun. That's working, so now I can shoot the things I need to shoot, and then, yeah, then we'll move on. So I think next week we'll be back in the office because I want to design that ROM card. So I think we'll work on that next week. And then that way, by about the time that board comes back, would anticipate that the parts that I need for it will be here as well. So we'll do that. So whatever time it is for you, wherever you are, subtract 3 hours from the current time, and that's when the stream will start next week. So you actually fixed one for your 16500? What was wrong? Like, couldn't have been one of the ASICs, right? So, okay, cool. Well, guys, thanks for hanging out. This was fun. Gosh, I wish that switch had worked. That's a bummer. Oh, wow. Cool. Back to previous schedule? No. I'm sticking to 1 p.m. Central Time US on Fridays for right now. So that's why I said it's whatever time it is right now minus 3 hours. So, okay. Take care, guys. Bye.